Done. That was good. Awesome. All right, so 11.1, this is our self-check. How are we going to do this? These are just pretty basic volumes. We want to find the area of R, so it's just going to be top minus bottom. Integral between 0 and 4. But the hard part is no calculator. So this is going to be the integral from the start to the end. The start is 0, end is 4. So 0 to 4 of top. And the top is the curvy function, so that's going to be our square root of x. And the bottom is our linear function, x over 2. So again, it's top minus bottom, square root of x minus x over 2. And that quantity is going to be multiplied by dx, our thickness. So from here, I can zoom in to make my handwriting look a little bit better. Oh man, yeah, I'm getting some like lag with the recording citrus. Again, this square root of x, I want to be thinking of that as x to the 1/2 power. So when I take the integral, it's going to go x to the power of 3/2, and then I divide down. What happened there? 3/2, then divide down by 2/3, or multiply by 2/3 essentially. And then I'm going to subtract. This was x to the power of 1. It's going to be x to the power of 2. And then I divide down. I have 4 now on the bottom. And then from here, this is evaluation bar between 0 and 4. Any questions up to this point?
No.
All right. So plugging in, I'm gonna plug in 4 first. So I have 2/3 of 4 to the power of 3/2 minus, this is going to be 4 squared over 4. I should put parentheses around this whenever I do my substitution, just be careful. And notice what happens if I plug in 0. So technically I should be saying all of this thing minus, okay, now I'm going to plug in 0, but when I plug in 0, 0 to the power of 3/2 is 0, times 2/3 is 0, minus 0. This is all going to be 0, so I'll say 0 minus 0. Just to show that, yes, I did plug in 0. And then from here, you just need to figure out what 4 to the power of 3/2 is kind of the hardest step from here. Let me do some scratch work up here. So 4 to the power of 3/2 is the same thing as 4 to the power of 1/2. All of that to the power of 3, which is equal to the square root of 4 to the power of 3, which is equal to 2 to the power of 3, which is equal to 8. So 4 to 3/2 is 8. So I come back down here. I can say this is now equal to 2/3 of 8, 2/3 of 8, minus, and again, then 4 squared over 4. I have 1 4 on the top, 1 4 on the bottom. So the trick here is you can cross off a 2, cross off the 4, and I'm just left with 4. And then from here, I know that this 3 is not going to go away. So my next step is to multiply this 4 by 3 over 3. And 8 times 2 is 16. So I have 16 over 3 minus 12 over 3. Put parentheses around this. And then that's basically all I need to do. 16 minus 12 is 4. So the answer here is 4/3. And box it. Zoom out so we can see more of the problem. Any questions on part A?
No.
There's no real scoring guide that I should be able to find the scoring guide though. This is 2009 Form B. Let me find the scoring guide later because it's more important to just know how to do these problems. We already have 5 minutes left. For part B, we are finding square cross sections, right? Square cross sections. So you need to know the formula for a square. If you don't know that, the volume is equal to the integral from A to B. Oh my gosh, my handwriting is deteriorating so bad. Integral from A to B of, that's going to be top minus bottom quantity squared, dx. So when I actually start plugging things in, my integral is going to be the integral still from 0 to 4, and that hasn't changed. And my top is still square root of x. So I come back down here. This is going to say square root, I don't know what I'm doing up there, square root of x minus x over 2. That quantity squared now, dx. That's the only extra thing that I have to do. So what's going to happen here? If it was a derivative, we'd go down, bring it down, but you can't do that. So the only way to do it with an integral is to actually square out this binomial. And there's a few ways of doing that. I like squaring the first, doubling the product, and squaring the last. That's a shortcut that I like to use. But you could also just use the general rectangle and say if this is square root of x or x over 2, and this is square root of x and x over 2, and then you can find each of the area of the cells, but I'm going to do the shortcut, and I hopefully will, I guess I should say, I hopefully will see you doing it as well. So if I square the first, I still have the integral here. So if I square the first, I'm square root of x squared is x. If I square double the product, so the product here of x, this is really x to the 1/2. So what's x to the 1/2 times x to the 1? I add their exponents. So 1 plus 1/2 is 3/2. So multiplying them together without multiplying by 2 looks like this. X to the power of 3/2 divided by 2. That is the product of, I should say negative. That is the product of x to the 1/2 and negative x over 2. The product is this. But I don't add the product, I double the product. So I'm going to be multiplying by 2, and these 2's will cancel out. So I can just go like this. I can say x minus x to the 3/2. And then from there, I'm going to square the last. So squaring this negative x to the, or negative x over 2 is going to be positive x squared over 4. So positive x squared over 4. And then all this stuff is still times dx. And I guess I can change this all to yellow as well, or orange, to be consistent. All right. And now, yeah, all this stuff dx, to be formal about it. All of this stuff dx. Okay, now we have to actually take the integral. So the integral of x to the power of 1 is x to the power of 2 divided by 2. X, how much room do I have? I have plenty of room. Okay. X to the power of 2 divided by 2 minus, okay, this can go up to the x to the power of 5/2, divide down, and that's the same thing as multiplying by 2/5. And then this is going to be plus x to the power of 3, and then divide down, it's going to be x over 12. Or x to the power of 3 over 12. And that's the evaluation bar between 0 and 4. Any questions up to this point?
No.
Okay. Let's start plugging things in. I think I do need to go down to the next line. I do. Okay, so next line down here, I'm plugging in the 4. Notice that when we plug in 0, I'm going to get 0 minus 0 plus 0, and nothing's going to happen. I really only need to plug in the 4, and I'm done. So I have 4 squared over 2 minus 2/5 of 4 to the power of 5/2 plus 4 to the power of 3 all over 12. And then I can go ahead and say minus 0 plus 0 to show that, yes, I did plug in the 0 as well. You don't need to do that. I'm just doing that for notes. Okay, time to simplify this guy. I'm thinking I'm just going to go down from here. So 4 squared is 16. 16 divided by 2 is 8. 4 to the 5/2. Let's do some scratch work. Do I have any room up here? So I'm going to do it up here. So what color am I using? I'm using orange again. So 4 to the power of 5/2. I'm going to skip some steps now. That's the same thing as the square root of 4 to the power of 5. And 2 to the power of 5 is equal to, is that 32? I think it is. 32 and... No, oh, it's 64. Dang it. 2 to the power of 4 is 32. 64. And if you want to check, I can use my Spotlight search. If I pull up my Spotlight search, you guys can't see that, right? I have it open right now. You can't see it. Okay, oh well. It's 32. So 8, and this is going to be minus 2/5 of that 32 that we just found. 64. 2/5 of 64 plus 4 to the power of 3. Well, notice that there's a 4 on the top and a 4 on the bottom. So I'm going to cross off one of these 4's and change that to a 2. Cross off one of these 4's and turn it into a 3. So I really have 4 squared over 3, or I really have 16 over 3.
Sindel, isn't it 32? Because first you square root the 4 and get 2, so then it's 2 to the power of 5 and it's 32?
Yes, you were right. I was wondering what was going on. Thank you.
Yeah.
I was multiplying by the 2 ahead of time. Yeah, logged it.
It's across the room. I'll do it later.
For sure. All right, and then from here, simplifying a little bit more. I know that I'm going to have a common denominator of 15. Okay, here we go. I'm going to multiply by 15 over 15, multiply by 3 over 3, multiply by 5 over 5. What is that going to give us? So 8 times 15 is 120. because 8 times 10 is 80, 5 times 8 is 40, 80 plus 40 is 20, yeah, 120. So 120 over 15 minus, okay, so 3 times 2 is 6. Maybe it's easier to do. 2 times 32 is 64. 64 times 3 is 192. Hopefully someone can check that. 192 over 15. And then plus 16 times 5, that's going to be double 120, so that should be, oh no, that's 80, yeah, thank you. 80 over 15. Cool, they all have like denominators. So from here, I have 80 plus 120 is 200. 200 minus 192 is 8. So I have 8 fifteenths. Use red. 8 fifteenths. And that is our final answer. My 5s are not very nice. Okay, 8 fifteenths. Cool, and that's the answer they got from last year. So that checks out. And then our final question, C, write but do not evaluate. This is going to be the integral. I have pi also because I'm rotating, right? So I'm rotating. Whenever you see the word rotate, have a pi. 0 to 4. Okay, so it's going to be outer minus inner. Where's y is equal to 2? I should graph that. Y is equal to 2 looks like this. Okay, so that means my outer function is actually x over 2. So x over 2 should be my first one. So I have x over 2 and then minus the k value here. So minus 2, that quantity squared minus the inner. So the inner is the square root of x minus 2, that quantity squared. And then all of this stuff, so I'll put square brackets here, square brackets, all that stuff, d of x. And done.
Question. So
yeah, go for it.
I just made x over 2 and x square root of x, like I put like in the opposite sides. Do I need to like rearrange that?
Yeah, so you have to have it rearranged. It has to be the outer minus the inner. Because if it's not, you're going to get a negative answer, which is incorrect. So yeah, if you ever are saying what is the actual volume and you calculate on your calculator, you'll get the points because you'll realize, oh, oops, I got a negative, and then you'll make it positive and you'll get the full points. But if it ever asks to write but do not evaluate, it has to be correct because that's all you have.
All right.
Yeah, good question. Other questions on any of 11.1? All right, cool. Then we have 10 minutes to do 11.2. Good luck. Record. All right, we're currently being recorded. All right, so 11.2, here we go. And let me minimize you guys. Find the area of R. So the question here is where do these intersect and which one is on top? So let's find, what's going on here? There he goes. Find bounds. So to do that, I'm going to set them equal to each other and figure out where they intersect. So square root of x is equal to x over 3. I'm going to square both sides. Wait, is that what I want to do? Yeah, so square both sides, and I'll get x squared is equal to, sorry, not x squared, x by itself, because I've canceled out the square root, is equal to x squared over 9. Where does that happen? Well, I can put them both on the same side and then multiply everything by 9. So I get I'm going to subtract an x, essentially. Subtract an x on both sides. And then I get, I'm realizing that I don't have very much room, so I need to push this over here.
Don't you have to multiply by 9 first?
You could do either way, yeah. So multiply by 9, and I get 9x is equal to x squared, and then I can subtract a 9x, and I can get x squared minus 9x is equal to 0. And then from there, factor. So factoring this thing gives us x times the quantity of x minus 9 is equal to 0. And from there, using the zero product property, that means x is equal to 0 and x is equal to 9. So we found the bounds 0 and 9.
What if you divided by x once you got to the 9x equals x squared part? You got x equals 9 and you knew that the first bound was going to be 0 because...
So you knowingly divided by 0? You knowingly committed a mathematical sin? You said you divide by x, and x is 0. Didn't you just say that?
I divided by x in terms of x being 9.
You essentially factored it out. Yes, that's fine. So which let's graph it. Do you guys remember what the graph of square root of x looks like? If not, now is the time to remember. It looks like that. And what does x over 3 look like? Well, it's a flat line. It's x equals, it's just a line. It's a linear function. So it looks like that. So that's x over 3, and this is the square root of x. So the top function is the square root of x. So I should be doing square root of x minus x over 3. So here we go. Setting up our integral. Let's do a little wavy line over here. So this is going to be the integral between 0 and 9, those bounds we found over here. And it's going to be top minus bottom, so square root of x minus x over 3, all that stuff, d of x. All right, so you guys have seen this many, many times. This is really x to the 1/2. If I take the integral of him, the antiderivative is x to the power of 3/2, and then divide down its 2/3. And then this is going to be x to the power, so minus x to the power of 2 divide down over 6. And I don't know why I wrote it so far over to the right. Let's squish it right there. And this is going to be evaluation bar between 0 and 9. And then plugging these in, don't have to worry about plugging in 0, but when I plug in 9, I get 2/3 of 9 to the power of 3/2 minus 9 squared over 6. Okay, next step. 9 to 3/2, you can probably do these in your head now. Square root of 9, because divide by 2, is 3. 3 to the power of 3 is 27. So this is saying 2/3 of 27. And then minus 9 squared, so that's 81 over 6. Okay, then I just have to reduce the fractions, essentially. So what have we got here? We've got 27 and 3. I can divide top and bottom by 3, and that's going to be left with 9 on the top, and then 9 times 2 is 18. And then from there, I have 81 over 6. I can reduce by dividing the top and bottom by 3. Divided by 3 gives us 27 over 3. And, oh, sorry, 27 over 2. Blech. 27 over 2. So this is going to be, what did I say, 18 minus 27 over 2. And 27 over 2, the decimal approximation of him is 13.5. So I'll write above here, that's 13.5. What's 18 minus 13.5? 4.5. 4.5. All right, that was part A. Let's do part B. We have 4 minutes left before you can take your break. So we have square cross sections. So square cross sections, again, is top minus bottom quantity squared. So integral between 0 and 9 of top, square root of x, minus bottom, x over 3, quantity squared dx. Then we just have to do this. Again, you need to remember how to square the first, double the product, square the last. So squaring the first is going to be x. Doubling the product. Well, the product is normally x to the power of 3/2 over 3, negative. How do I get that? Well, this is x to the power of 1/2, and 1/2 plus 1 is 3/2, and then divided by 3. Doubling the product, boom, just add a 2 in front. And then squaring the last is going to be plus, because it's always plus. When I take a square, it's going to be x squared over 9. Evaluation bar between 0 and 9. Darn it. Okay, so I have to rewrite my integral. Integral from 0 to 9, and then that is going to be now equal to x squared over 2, and then this is going to be minus, I still have my 2/3 out front. This is x to the power of 5/2 now, and then times 2/5, and then plus x to the power of 3 over 27. Now that I've taken the integral, I can do evaluation bar from 0 to 9. Does that look good?
Yeah.
So far? Cool, thank you. Plugging in, we have 9 squared over 2 minus 4/15 of 9 to the power of 5/2 plus 9 to the power of 3 over 27. And again, you don't need to worry about plugging in 0 because all these are going to turn into 0. From here, what do we have? I guess I can go down instead of to the right. So I have 81/2 minus, okay, so 1/2 is going to be 3 to the power of 5. Oh gosh, that's a big number. What is that? 3 to the power of 5 is 243, and then 243 times 4 is 972. Is that right? Oh my gosh, that feels like it's too big. 972 over 15 plus 9 to the power of 3. Well, this is 3 to the power of 3 on the bottom. So this is really 3 to the power of 2 to the power of 3. And then on the bottom I have 3 to the power of 3. So I really have 3 to the power of, I multiply 3 to the power of 6 over 3 to the power of 3. And you can kind of subtract, so it's 3 to the power of 3, which is just 27. Alright, so some of these things cancel out. So I know that this is divisible by 3 on the top, so let's go ahead and divide that by 3. That's going to be 372 divided by 3 is it 24, I think? Let me check. 72 divided by 3 is indeed 24, so 324 over 5. And I have 81 over 2. I think I need to multiply everything, so I have a common denominator of 10. I guess I can check my notes too. Yep, that looks like exactly what I was doing. So multiply everything, so this is now going to be, let's do a different color here, blue, sure. Multiply by 5 over 5. 5 times 81, half of 81 is 40.5, so 405. 405 over 10, then double this is going to be minus 648 over 10, plus, and then times 10, so 270 over 10. When I add all these together, I think I get, let's see, the easiest way to do this is saying 270 and 405 is going to be 675. So that's going to be 100. Oh no, so 675. What's going on here? 675 minus 648 is just 75 minus 48, and 75 minus 48 is 27. Okay, yeah, so that's 27 over 10, and that's 2.7, which is the answer we got last time. So 27 over 10 or 2.7. Either of those two answers will work. I'm going to leave it as a decimal because that's what we've been doing before. And then finally for part C, let's zoom in here. For part C, write but do not evaluate. When we rotate around, y is equal to, that's a negative 2. It's just really written poorly. This one is a little bit tricky. Again, whenever you see the rotate, you automatically think pi, and then it's integral, the same bounds, 0 to 9. And this is going to be the outer minus the inner. So outer is going to be a little bit changed now. So if I do y equals 2, my graph has y equals 2 is probably right up around here. So the outer function is going to be x over 3. So it's going to be x over 3, and then minus negative 2. Because I'm doing a double negative, I'm really doing plus 2. So that is the outer squared plus, oh wait a second. No, I'm wrong, aren't I? Let's come back here. I'm doing negative 2, not positive 2, which means this line back here should be down here at, well, down here at negative 2. So it's definitely down below here. I'll say that's y equals negative 2. So then my outer function is actually square root of x. That's my bad. This is going to be the square root of x, again, plus 2 because minus minus 2, that quantity squared. So that's the first radius. And then I'm going to subtract the other radius, and that's going to be x over 3 minus negative 2, which is again plus 2, that quantity squared, and then all of that quantity dx. So all of this quantity dx. Cool. And that concludes our self-check 11.2. Let me see if I can go find some grading. Like, what does the scoring guide say?